Welcome to today's deep dive. It's funny how we often take everyday things for granted.
Mm-hmm.
Take chlorine, for example.
Right.
I mean, we all know it's in our swimming pools
Yeah.
and keeps our drinking water safe.
Sure.
But this element, well, it has a past that's both fascinating and honestly a little bit frightening.
Yeah.
So today, we're going deep,
Okay.
unpacking chlorine's journey.
All right.
From a misunderstood gas to, well, the ultimate multitasker of the chemical world.
I like that.
And to guide us through this, we've got a stack of sources here.
Okay.
From the Royal Society of Chemistry
Right.
to some intriguing scientific journals.
All right. Let's do it.
So are you ready to dive into the world of chlorine?
Absolutely. What's so captivating about chlorine is that it embodies this incredible duality.
Yeah.
It's essential for life,
Right.
yet it's been weaponized throughout history.
It's true.
Understanding how something can be both beneficial and dangerous is key to unlocking its secrets.
That's what I find so intriguing.
Yeah.
It's like a real-life Jekyll-and-Hyde scenario.
It really is.
And to think,
What's that?
we've known about chlorine in some form for centuries.
Really?
I mean, common table salt,
Yeah.
sodium chloride,
Right.
that's been around since ancient times.
Precisely.
Well-
It just goes to show how something so seemingly ordinary can have this hidden depth to it.
Yeah.
But to really get to grips with chlorine, we need to start with its basic identity.
Okay.
Chlorine is a halogen, sitting right there in the 17th spot on the periodic table,
Gotcha.
sandwiched between fluorine and bromine.
Okay, so we've got chlorine in the halogen family, element number 17. But what does it actually look and act like? I mean, I wouldn't know chlorine if it knocked on my door.
Well, in its pure form, chlorine exists as a yellowish-green gas at room temperature. It's denser than air, which becomes important later on when we talk about its less desirable uses.
Okay, denser than air. Got it. Now, our source has mentioned something about chlorine being highly reactive
Yes.
and always looking to gain an electron. What's that all about?
That's where things get really interesting.
Okay.
You see, atoms crave stability,
Right.
and they achieve that by having a full outer shell of electrons.
Okay.
Chlorine is just one electron shy of a full outer shell, making it incredibly eager to bond with other elements that can provide that missing electron.
Okay.
That's what we mean by reactive.
Right.
It's quick to pair up and doesn't like to be alone.
So chlorine is like that friend who always forgets their wallet,
Yeah,
always on the lookout to complete its set, so to speak.
that's one way to put it. But this inherent need to bond is also what makes chlorine so incredibly versatile and important in so many different applications.
Okay, so we've got this reactive, electron-hungry element
Right.
hanging out on the periodic table.
Yeah.
But how did we even discover it? Was it some dramatic eureka moment?
It was a significant discovery, for sure, but
Yeah.
perhaps not as dramatic as you might imagine.
Okay.
Back in 1774, a Swedish chemist named Carl Wilhelm Schell first isolated chlorine. He combined manganese dioxide with hydrochloric acid, and voila,
Yeah.
this strange yellowish-green gas emerged.
So Scheele manages to isolate chlorine. Case closed, right?
Not so fast. You see, the tricky thing with chemistry, especially back then, was that identifying a new element was only half the battle.
Oh, really?
Understanding its properties and how it fit into the existing scientific knowledge
Right.
was a whole other challenge. And in this case, Scheele, brilliant as he was, made a bit of a blunder.
Great.
He mistakenly believed that chlorine was a compound containing oxygen, an oxide, rather than an element in its own right.
Wow, that's like finding a lost Van Gogh in your attic and assuming it's just a child's doodle.
Huh.
So how did we go from this misidentified gas to recognizing chlorine as the chemical superstar it is today? And what about those applications you mentioned?
Oh, yeah.
I'm ready to hear about chlorine's greatest hits.
Well, it took some time for the scientific community to, fully understand chlorine. One of the earlier uses actually highlights how chemistry was evolving back then. You see, chlorine plays a key role in creating aqua regia.
Aqua regia. That rings a bell.
It's a mixture of concentrated nitric acid and hydrochloric acid, optimally in a molar ratio of 1:3. And it gets its name, which means royal water, from its ability to dissolve the noble metals gold and platinum, though not all metals.
So chlorine helps create this royal water that can dissolve gold. Can already see where this is going. Alchemists, lost treasures, the whole shebang.
You're not far off. Aqua regia and chlorine by association has a long and colorful history. There's even speculation that it might have been used in the Spanish conquest of the Americas.
Hold on. Are we talking about conquistadors using chlorine to melt down stolen gold? That's a story for another deep dive.
Indeed. But it just goes to show how chlorine's reactivity, its ability to break things down, has been known and utilized for centuries.
Okay, so we've got chlorine dissolving gold, aiding in historical conquests. But how did we go from that to the chlorine we know today, the kind we use in everyday life?
That's where the ingenuity of industrial chemistry comes in. As demand for chlorine grew, so did the need for, well, a more efficient, and let's face it, less hazardous way to produce it. Early methods relied on some rather unpleasant and dangerous reactions.
Less than ideal, to say the least.
To put it mildly. But then came a game changer, the chloralkali process. It's an elegant method that uses electrolysis, basically running an electrical current through a solution, to split brine, which is just salt water, into its components. You get chlorine gas, hydrogen gas, and sodium hydroxide, all valuable chemicals in their own right.
So it's like a 3-for-1 deal. But
Yeah.
just to clarify for those of us who aren't, chemistry whizzes, what's electrolysis exactly?
Imagine it like this. You have a battery connected to 2 electrodes dipped in a saltwater solution. The electrical current forces the positive sodium ions to one electrode and the negative chloride ions to the other. This separates them, allowing us to collect chlorine gas.
Ah, so we're essentially using electricity to pry apart the elements in salt water. That's pretty clever. And that brings us to, I think, one of the most remarkable aspects of chlorine, its role in public health. It's hard to imagine life today without clean, safe drinking water.
And chlorine deserves a lot of credit for that. Its story in public health is intertwined with the fight against cholera, a deadly waterborne disease.
Right. I remember reading about this in one of our sources, the Royal Society of Chemistry website. It mentioned how chlorine's use in water treatment became widespread as a way to combat cholera outbreaks.
Exactly. It revolutionized public sanitation. But even before that, there's a fascinating, albeit accidental, contribution chlorine made to medicine.
Oh, yes. The story of Ignaz Semmelweis. Now, this is where chlorine's duality, its ability to be both harmful and helpful, really comes into play.
Absolutely. Semmelweis, a Hungarian physician, was working in the mid-1800s before the germ theory of disease was fully understood. He noticed that doctors who went straight from dissecting cadavers to examining patients had a much higher rate of transmitting childbed fever, a devastating infection that affected new mothers.
Talk about a scary thought, going from a dissection to a delivery room.
Without knowing the exact cause, Semmelweis had a hunch that something was being carried on the doctor's hands. He insisted they wash their hands with a chlorine solution, and the results were dramatic. Childbed fever cases plummeted.
So even before we knew what germs were, chlorine was already helping us fight them. It's like an unsung hero of early medicine. But of course, chlorine's reactivity, this power to sanitize and disinfect, also has a darker side.
That's the unfortunate reality. Chlorine's effectiveness in one context can make it incredibly dangerous in another, and its use as a chemical weapon is a chilling example of that.
It's unsettling, to think that something so beneficial could be turned into a weapon like that.
It really makes you think about the nature of discovery, right?
It does.
That power to do good can so easily be twisted.
Yeah.
And the stories from World War I, those accounts of chlorine gas attacks.
Awful. Just awful.
That vivid imagery.
It's haunting.
The yellowish-green cloud, the unexpected smell, then that burning in the lungs, the panic.
It's a stark reminder, isn't it, of how dangerous chemistry can be when it's misused. And it's not just history either. What we read about those recent incidents in Syria and Iraq.
Sadly, it shows that the threat is still very real.
It makes you appreciate the good uses even more, I think. Like how essential chloride ions are.
Absolutely. It's easy to focus on the negative, but we can't forget how much we rely on chloride.
Right.
It's maintaining the fluid balance within our cells, allowing our muscles to contract properly, even helping our nerves send signals. It's all connected.
It really is incredible when you think about it. All those tiny chloride ions just working away behind the scenes to keep us going.
Exactly. And if you recall, we talked about chlorine wanting that extra electron.
We did, yeah. Always trying to complete the set.
Well, when it gains that electron, it becomes a chloride ion. And that negative charge is what allows it to interact with positively charged ions, like sodium. And what do you get? Sodium chloride, table salt.
Full circle. But we can't just ignore the risks, can we?
We can't. Chlorine is powerful, and like anything powerful, it needs careful handling. The OSHA guidelines really emphasize that.
They do. Those safety precautions are no joke.
Even small exposures can irritate your lungs, and higher concentrations. Incredibly dangerous. Remember how we said chlorine is denser than air?
Yeah, it sinks, right?
Exactly. So in case of a leak, it's going to settle in low-lying areas. Really important for emergency responders to know.
And not just in labs or factories either. I was struck by that example about mixing cleaning products, something so many people do without a second thought.
You're right. It's a surprisingly common household hazard. Bleach already has a chlorine-based compound in it. Mix that with something like ammonia. You're creating toxic chlorine gas right there in your home.
So rule of thumb, unless you're 100% sure it's safe, don't mix your cleaning products.
Exactly. And it's not just immediate danger either. Think long-term. Chlorine can affect materials too. Take stress corrosion, cracking in stainless steel, for instance.
What's that?
Imagine the steel like tightly packed fibers. Over time, chlorine can actually work its way in between those fibers, weakening the bonds, makes the steel more likely to crack under stress.
So, like the saying, water wears away stone. Except it's chlorine slowly breaking down metal.
A good analogy. It just goes to show even something we use to keep our pools clean can have this destructive side too.
Amazing, isn't it? All these facets to one element. We've covered ancient salt mines, the horrors of World War I, the chlorine that keeps our pools safe, and the chloride ions in our bodies.
From the mundane to the life-saving, Chlorine's story has it all.
It's been quite the deep dive.
It has. And as always, we've just scratched the surface.
Barely dipped our toes in, really.
There's so much more to explore. Chlorine's role in plastics, its environmental impact, the ongoing research into new applications.
It makes you think, doesn't it? Even something like chlorine, which seems so ordinary, has this whole hidden world behind it.
That's the beauty of chemistry. It's all about discovery, understanding, and finding ways to use the elements around us for good.
Beautifully said. Well, on that note, we'll wrap up our deep dive into the world of chlorine. We hope you've enjoyed this exploration as much as we have.
Thanks for joining us.
Until next time, keep asking questions, keep learning, and remember, there's always more to discover.